Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, still paying tribute to the mighty Beatles. One last example for Solids of Revolution, finding volumes. So this is part 3. Thank you, Sir Isaac Newton. Thank you, Gottfried Wilhelm Leibniz. One more example. This should go fairly quickly. One arc of y equals sine x is rotated through 360 degrees about the x-axis. Find the volume of revolution. So let's do a quick sketch of that. So you better know what sine looks like. That was a horrible line. So you better know what sine looks like. One arch. Oh my gosh, what a horrible line. Here is y equals sine x right there. Just for kicks, you better know that's pi. And we are going to rotate that about the x-axis. I can't even begin to draw what that rotation would look like. I'll show you in a second. Okay, and so this is y equals sine x. Okay, and if we rotate that, we're going to get a football-looking thing. So what's the volume of that guy? Well, here we go. We're going to use my formula. Volume equals the integral from a to b of pi y squared dx. But what does y equal? Excuse me, y equals sine x. So this is going to be the integral from 0. You do have to know that that intersection point is pi. From 0 to pi. I'm going to factor out the pi, put it out front, of sine x, and it's squared, so I have to square it, sine squared x dx. We do not know how to integrate sine squared x, so we have to go to our formula sheet. Here we go. And either we already know this by heart or we can solve for it, so we can substitute for sine squared x. Little bit of algebra, trigonometry going on here. I know that cosine 2 theta equals 1 minus 2 sine squared theta. And if I subtract 1, I get negative 1 minus cosine 2 theta is equal to negative 2 sine squared theta. And why did I write minus in front of that cosine? I have no idea. This is positive. Divide by negative 2 and I get 1/2. Now comes the minus. Minus 1/2 cosine 2 theta is equal to sine squared theta. What does that do? Well, I can substitute 1/2 minus 1/2 cosine 2 theta for sine squared theta because I know how to integrate that. So integral of pi from 0 to pi of 1/2 minus 1/2 cosine 2x dx. Yeah, baby. So let's move up here. We're going to integrate it like it's 1999. So that's okay. I forgot the pi. Pi times the integral of 1/2 is 1/2 x. And we have a cosine of ax plus b situation. So minus 1/2 multiplied by 1 over a. My a is 2, so that's times 1/2. And then I integrate as usual. The cosine of blah, the integral of a cosine of blah is sine of blah, so that becomes sine 2x. All done now, evaluated from 0 to pi. Clean that up a little bit. I have pi times the integral of 1/2, or not the integral, pi times 1/2 minus 1/4 sine 2x. Evaluated from 0 to pi. Now we're doing some evaluating, so that would be, oh, you know what? I didn't put x here, did I? This is 1/2 x. 1/2 x. I'm glad I caught that. The integral of 1/2 is 1/2 x. I said it, I just didn't write it. So this becomes pi times 1/2 pi minus 1/4 sine of 2 pi. Okay. Let me put brackets around here because it's pi times everything. Minus, now I'm going to replace x with 0, and I'm hoping that it's all going to be 0. 1/2 times 0 is 0. Sine of 2 times 0 is sine of 0, which is 0. Yeehaw, snickerdoodle. Okay, so now just a little bit of trig and algebra. Sine of 2 pi is also 0. So this becomes pi times 1/2 pi. Pi times pi is pi squared. So the volume is equal to pi squared over 2 cubic units. And that is equal, that is all we can do with that. I think that I have done all the damage I can do. So I'm going to stop it right there. I am out.